All right, the key to problems number 17 through 24 is drawing an accurate picture. So let's start with number 17. At a point on the ground 80 feet from the base of a building, the measure of the angle of elevation at the top of the building is 51 degrees. Find the height of the building. So there's a building, I want the height, and it says the angle of elevation to the top. So if someone's standing over here looking at the top, that angle of elevation is 51 degrees. And it says at a point 80 feet from the base. So 80 feet from the base to the point on the ground. So that's 80 feet. So if you look at that picture, that's what we're going to try and solve. So let me draw that a little bit bigger. So 80 feet, we are looking for the height of the building, and we had a 51 degree angle of elevation. This is a simple tangent problem. The opposite side is what I want, the adjacent side is what I have. So the tangent of 51 should equal the height of the building divided by 80. So the tangent of 51 is 1.2348. That should equal h over 80. So I'm going to get h times 1 is h. And when I multiply that 1.234 times 80, I end up getting the height is 98.8 when I round to the nearest tenth. So the height, 98.8. And number 18, find the measures of the acute angles of a 3, 4, 5 right triangle. Well, let's just draw a right triangle and put sides of 3, 4, and 5 on it. So I'm looking for the measures of the angles. Well, I know one of them is 90 because it's a right triangle. So I need to find angle X and angle Y. So again, let me draw that for you a little bit bigger so you can see it. A 3, 4, 5 we know is a right triangle, and we're looking for angle X. Let's just start with X. You have your pick of the litter, whatever you want here. I'm going to use sine, the opposite side 4 and the hypotenuse of 5. So the sine of that angle X should be the opposite side 4 over the hypotenuse of 5. Well, when I want to know the angle, this is when I have to say, calculator, give me the sine inverse of this ratio, because then the calculator will tell me what is the angle that has that ratio of 4 over 5. So I type in 4 divided by 5, which is 0.8, and then I hit second sine inverse, and I'm getting that that's a 53 degree angle, 53.1, but I'm rounding to the nearest degree. So 53. The other angle, I'll call it angle Y, is the same idea. I'm even going to use sine again. The opposite of Y is 3, hypotenuse is still 5. So the sine of angle Y should be 3 over 5. So that means if I take the sine inverse of 3 over 5, I should get an angle of 36.8, which we're going to round to 37 to the nearest degree. And some of you are probably thinking, well, I could have just subtracted from 180. Yeah, you could. I'm just going to do it this way to make sure that it still matches up. 53 and 37 is a total of 90, plus the third angle of 90 degrees makes a total of 180. It works. So the measures of those two angles would be 90, 53, and 37. And that's on every 3, 4, 5 right triangle. Number 19, a rhombus has sides of 12 and a 76 degree angle. So if I draw a rhombus, I try and keep my sides the same. All the sides are 12. And it has a 76 degree angle. So I'm going to put the 76 degree angle over here. Find the lengths of the diagonals. We've actually already done this problem before. You just have to draw the picture for yourself. So I'm looking for diagonal 1 and diagonal 2. Notice when I draw that the diagonal is going to cut that 76 degree angle. Was 76, right? Yeah, 76 degree angle in half. So again, draw this a little bit bigger for you. This 76 degree angle, when I draw this diagonal, is going to get cut in half into 38 and 38. And if the sides are 12, when I draw the other diagonal, this is going to give me 90 degrees. And I'm looking for this side of X and this side of Y, because I know that this is also X and this is also Y, because the diagonals get bisected. So I'm just going to draw that right triangle with sides of X, Y, the 90, and my 38 degrees. I'm going to use my basic trig here. This is a tangent relationship, so the tangent of, I'm sorry, no it's not. The side we know was 12, which is the hypotenuse. So this is going to be a sine relationship. The opposite side of x over the hypotenuse of 12. So the sine of 38 is going to equal the opposite side x over 12. I multiply, cross multiply, x times 1 is x. 12 times the sine of 38 is 7.4. But I have to double that, so times 2 is going to give me the diagonal 1 is 14.8. I'm going to do the same exact thing to find the other diagonal, because the other diagonal is made up of two pieces of y. So I'm going to use that 38 degrees, but this time y is the adjacent to that 38 degrees, so it's going to be the cosine of that 38 equals the adjacent side y over the hypotenuse again, which is 12. So I put that over 1, y times 1 is 1, and when I take the cosine of 38, cross multiply by the 12, I end up getting 9.5. But again, I have to double that 9.5 to get the total length of diagonal 2, which would be 19. So my diagonal lengths in that rhombus with a 76 degree are going to be 19 and 14.8. So again, make sure you understand those properties of the rhombus. Problem number 20, a road climbs at a 5-degree angle. What is the grade of the road? Keyword here is grade. Grade is always a percent, and the percent is always what percent am I rising for every 100 feet. So if I have a 5-degree angle, I'm looking for what is this height? How much am I rising? So when I draw that, how much am I rising for the 100 feet that I've gone across if I'm rising at a 5-degree angle? So this is a tangent problem. The tangent of that 5 degrees should equal the opposite side x over the adjacent side 100. So the tangent of 5 is 0.0874. That should equal x over 100. I cross multiply, x times 1 is x, and the 0.0874 times 100 is going to be 8.74. So we're just going to round that to the nearest tenth, and we're going to say this is an 8.7% grade, because it's 8.7 up out of 100, so that's 8.7%. Problem number 20. You're flying a kite and have let out 80 meters of string. Well, if I'm flying a kite, I'm over here, and the string, I've let out 80 meters, and my kite is flying up here. The kite's angle of elevation with the ground is 40 degrees. So 40 degrees here. If the string is stretched straight, how high is the kite above the ground, which is this length right here? So if I take that picture and I just focus on the triangle, it's going to look like this. You've got 80 feet of string that you've let out. How high is that kite if the angle of elevation was, sorry, I forgot, angle of elevation was 40 degrees. So if that's a 40-degree angle, I want to know the height. Well, that's the opposite side and the hypotenuse. So the sine of 40 will equal the opposite side over the hypotenuse of 80. So think of that as over 1. X times 1 is x. I just need to take the sine of 40 multiplied by 80. And when I do that, I end up getting 51.4 feet above the ground. It's going to be 51.4. Number 22, use what you know about a 30, 60, 90 triangle to find the exact value for the tangent of 30. All right, well, I know all three sides of the basic 30, 60, 90. So the side across from 30 is 1, across from 90 is 2, and across from the 60 is always root 3. So when it asks me for the tangent of 30 degrees, the tangent of 30 would be the opposite side 1 over the adjacent side, which is root 3. So the exact value of that just requires me to do some simplifying. I can't leave the square root of 3 in the bottom, so I multiply top and bottom by root 3. So on the top I get root 3, and the bottom I get 3. That's the exact value for the tangent of 30, root 3 over 3. So if you got something like 1 divided by the square root of 3, you would have had like 0.577. You did that right, but I'm asking for the exact value. I don't want a rounded value. So root 3 over 3 is what I'm looking for there. So this would be root 3 over 3. Number 23, a helicopter is hovering over a landing pad 100 meters away from where you're standing. So if you're standing over here, helicopter is hovering over the pad over here, and you're 100 meters away. The helicopter's angle of elevation with the ground is 12 degrees. So from the ground looking up, that's 12 degrees. What is the altitude of the helicopter? So I'll call that A for altitude. Again, let's draw this a little bit bigger so you can see it. So looking up at the helicopter, 12-degree angle, I'm 100 meters away. How high is that helicopter, or what's the altitude? Well, I have the opposite side is A, the adjacent side is 100. That's a tangent. So like I said, you're going to use a lot of tangents here. Tangent of 12 has to equal that altitude over 100. So if I think of it over 1, the altitude is simply going to be the tangent of 12 times 100 from that cross multiplication. So the tangent of 12 multiplied by 100 is going to give me an altitude of 21.3 meters. And last but not least on this page, number 24, an airplane climbs at an angle of 18 degrees with the ground. Find the ground distance the plane travels as it moves 2,500 meters through the air. So it's traveling 2,500 meters into the air, and it's traveling up at an 18-degree angle of elevation. So find the ground distance. So we're looking for how far, if I was here and I was a truck trying to keep up with the plane, how far would I have to drive to be directly underneath it? So again, let's make that a little bit bigger. So plane's going 2,500. How far is it going along the ground if it's traveling at an 18-degree angle of flight? Well, this time I have the adjacent side and the hypotenuse. So the adjacent over hypotenuse is the cosine relationship. So the cosine of 18 would be the adjacent side x over the hypotenuse of 2,500. So again, over 1, I'm going to get x times 1 is x. I need to take the cosine of 18 times 2,500. So the cosine of 18 times 2,500. I'm getting that that's a ground distance of 2,377.6 feet. So the answer here ends up being 2377.6 for that ground distance. And it was meters, not feet.